Welcome back as we move on with group 4 elements, which are known as metalloids. They are known as metalloids as they can gain like nonmetals and they can lose like metals. So as metals, they tend to lose electrons from their outermost energy level, and whenever they behave like nonmetals, they tend to gain electrons into their outermost energy levels. For the first 20 elements, we have two metalloids, that is carbon and silicon, and they both can gain and also lose electrons. Carbon is atomic number 6, electronic arrangement of 2.4. It can gain 4 or lose 4 electrons from the outermost energy level, and by so doing, it has a valency of 4, and after it has gained and also lost, it acquires two types of ionic configurations. So because when it loses the 4 electrons from its outermost energy level, it will end up with a stable configuration of 2, like that one of helium. If it gains 4 electrons, it will end up with 8 electrons in the outermost energy level, and so we'll have 2.8. Next we have silicon with atomic number 14. So 2.8.4 is the electronic arrangement. It can again gain 4 or lose 4, so end up with a valency 4. When it loses the 4 electrons from the outermost energy level, it will end up with an ionic configuration of 2.8 once it loses the 4. If it gains 4 electrons into the outermost energy level, it will have 2.8.8 because the 4 that it will gain will be added into this outermost energy level, and so will become full with 8. So the ionic configuration will be 2.8.8. Next we have group 5, and once we go to group 5, remember we had said earlier on that members of group 5, let me write on top here, members of group 5, group 6 and group 7 are all nonmetals. Just as we said at the beginning of the sessions that members of group 1, 2 and 3 are metals. Group 1, 2 and 3 are metals. They react by losing electrons from their outermost energy levels. Group 4, that is in the middle, they are known as metalloids. They can fall onto any side. The side of metals, they lose electrons, and on the side of nonmetals, they gain electrons. Now group 5, 6 and 7 are nonmetals, and they react by gaining electrons into their outermost energy level. So when we come to group 5, then 6 and 7, they will also be gaining because they are nonmetals. So in this case, among the first 20 elements, we have two members of group 5. We have both nitrogen and phosphorus. Nitrogen, which has atomic number 7, electronic arrangement 2.5, so can gain 3 and so end up with a valency 3. The ionic configuration that it shall have once it has gained the 3 will be 2.8. Now that the 3 will be gained into this energy level which was not yet full, and so have 2.8. So that is the ionic configuration for nitrogen once it forms a stable ion. Then we have phosphorus with atomic number 15, so with the 2.8.5. So again it will be gaining 3, and so again end up with a valency 3. The ionic configuration for this one will be 2.8.8. Now that the 3 that it shall gain will be put into this energy level that was not yet full. For phosphorus, it behaves in a special way because we also have another type of phosphorus, though it is a bit unstable, with the same atomic number 15, the same electronic arrangement, but this time it can lose the 5 from the outermost energy level, and by so doing it will have a valency of 5. And for this one it will have 2.8 as the ionic configuration. Now that when it loses the 5, the outermost energy level will also be lost, and so it will remain with just 2 energy levels. Then just a reminder, and for those of us who are able to interpret information in agriculture, we have this P2O5. P2O5. We call it the phosphorus pentaoxide. The phosphorus pentoxide. Pentoxide is a short name for pentaoxide. So pent comes from the word penta. It is supposed to be phosphorus pentaoxide, but in the short form pentoxide, meaning that in this formula we have 5 oxygen. Before the formula was made, we had phosphorus with a valency of 5, so it means it is this phosphorus that we have put in this as the second one, and I have just said that this is the type of phosphorus that is unstable, meaning the stable phosphorus is this one with a valency of 3. So this one with a valency of 5 is the one that is used to form this phosphorus pentaoxide. So because with the phosphorus having a valency of 5 and oxygen in group 6 with a valency of 2, they are the ones that will exchange, and so we end up with P2O5. So I wanted to show you that even though phosphorus is in group 5 and a metal that is supposed to be gaining, it can also be unstable and lose the 5 instead of gaining the 3. So that is all. Next we shall go to group 6 and group 7, which are also nonmetals, and then finalize with the group 8 that do not have any valency because they neither gain nor lose electrons. They are actually the group 0 elements, that is the group 8. The members of group 8 do not have any valency. They do not react, because whenever we talk of elements reacting or atoms reacting, they can only do so by either gaining or losing, and because group 8 neither gains nor loses, they actually do not have any valency. So I hope you still continue to write good notes and make sure that you are following, and in case of any question anywhere you have not understood, you are welcome to ask any question anytime. Let's move on to group 6. Next we have group 6, where we have 2 elements, oxygen and sulfur. Oxygen has atomic number 8, electronic arrangement 2.6. It's required to gain 2 electrons, so the valency becomes 2. The same with sulfur, atomic number 16, so 2.8.6. Again required to gain 2, so valency becomes 2. When ions are formed, oxygen forms oxide ion, and now that it has gained 2, the ionic configuration will be 2.8. Because this energy level, which was not yet full, which had initially had 6 electrons, it will gain 2, so have 2.8. For sulfur, it will have a capital S 2 negative, the sulfide ion. Again, this energy level will be full with 8, so ionic configuration will be 2.8.8. Next, we go to group 7, where we have the halogens. So in this one, again, we have 2 elements, fluorine and chlorine. Fluorine has atomic number 9, electronic arrangement 2.7, so we'll be required to gain 1, so then we'll have a valency of 1. So you check on how many it requires to gain. So valence 1, it will form fluoride ion once it has gained 1, and the ionic configuration will be 2.8. Then we go back to chlorine, atomic number 17, 2.8.7. So we'll be required to gain 1, so valency is 1. And then forming the chloride ion with ionic configuration of 2.8.8. Finally, we have group 8. These are the noble gases, or the group 0 elements. These ones neither gain nor lose. They neither gain nor lose electrons. Why? Because they are already stable. And because we referred to valency as the number of electrons that an element or an atom gains or loses, now that they gain nothing, they gain 0 electrons. That's why they are referred to as the group 0 elements. Whenever you write their atoms, there will be no charge on top there. Let me give those examples of the noble gases among the first 20 elements. We have helium, we have neon, we also have argon. Whenever you are writing their atoms, there will be no charge up here, just as we saw in our previous video. They do not have ion. They never form ion, so there is no charge on top here, and no wonder they are referred to as the monoatomic gases, and they are also the group 0. So for these ones, they do not have valencies. They also do not react, because for any element or for any atom to react, there must be the gaining or the losing of electrons. So these ones, they are already stable, they do not react. That is as per the chemistry that we learn in our high schools. So make sure that you're still writing and following on everything that you're writing. So let me conclude this session by saying this. The major reason as to why we had these sessions, the ones that we have had for quite some time now, about how valencies are determined, is for the reason that whenever you are given questions on the periodic table, there are those letters that are provided, and there is always this information that you are provided with, that the letters that you are given are not the actual symbols for those elements. So the letters that you are provided with are the same letters that you're supposed to use whenever you're writing formulas of different compounds, whenever you're writing well-balanced chemical equations. So now that only letters have been provided, and those letters are unknown letters, they are just there to represent the actual symbols for the elements provided. How will you use them and know the valencies that they have, and so end up writing correct chemical equations? It can only be either for those letters their ions have been given, or you know the atomic number, and the atomic number is what will guide you in the writing of the electronic configuration, and by knowing whether it is gaining or losing, you are able to determine how many it was to lose or how many it is to gain, and then you know the valency. Once you know the correct valency, just be assured that it will be very easy for you to write the formulas for different compounds, the formulas for different gases if gases are involved, and generally you'll be in a position to write very correct chemical equations that are also well balanced. So do not ignore this backup information, as when you have it in the right way, the answering of the periodic table questions becomes very easy. We are still having in the near future more questions on the periodic table, so keep it right here. And now that you already know what we have just done today and in the previous videos about valency, I know it will be just simple for you to understand everything else that we shall continue with. So I'm really wishing you the best. If you're new here, you feel much welcome. You are now where you are supposed to be. This is the right place for you to be, where chemistry is made very friendly for you, and we do not shy. We start from the very lowest level and we go up building one another in the knowledge about chemistry. So feel much welcome. Tell a friend to tell a friend. Keep on subscribing. The new subscribers, thank you very much. The returning subscribers, thank you very much. Let us together build one another. You build me in the with the subscription, I build you in your chemistry grades with the help of God. So have a good time, and please always make good notes. You require them today and in the days to come. Thank you.